here we are for section 8. We're going to be working with data in the attributes table. And this is really a continuation of some of the analysis type stuff that we're working in. So kind of honing some of those analysis skills again, and this is really where the power of GIS comes from, to elucidate patterns and then to display those. When we're done with this section, you should be able to complete the following. Sort data in an attributes table, generate statistics and summaries from that attributes table, and then insert a graph into a layout, which is really kind of a fun trick. So let's take a look here. Our first question is, what's an easy way to explore patterns in attribute table data? We can examine this data in a few ways. We'll talk about them just very briefly, and then we'll get into our demo map and project and take a look at things. So sort allows us to see some features at the top of the attributes table, so it can sort from ascending or descending, so ascending from smallest to largest, descending from largest to smallest, alphabetically similarly. And you can sort on one field or another. And what's it called? A something sort. Well, let's just look at it really quick. So let's go ahead and open the Culverts attributes table. So we're back here in our GIS basics analysis demos that we'll kind of use through the rest of the quarter. And I'm going to open the attribute table for my Culverts layer. And let's see, if I was going to sort them based on something meaningful, like maybe the size of the culvert. Here we go. So I'd right click in the heading here, and I'm going to go custom sort. I don't know why I couldn't remember that term. So let's type that into our PDF, and then we'll come back here and do some sorting. Let's see, PDF, custom sort. That lets you sort on more than one attribute. Let's see. Summarize lets us examine attributes in our attribute table based on whether it lets us examine both text/categorical attributes as well as numeric fields. And that'll create a whole separate table of data. We'll mess around with that shortly. And then statistics looks only at quantitative or numeric fields. So statistics is used for quantitative or numeric fields. I know we talked about quantitative data earlier. That can also be referred to loosely as numeric fields. They're not exactly the same always, but they're mostly overlap. So how do I sort the attributes table? You're going to right click in the title, which you just saw me do briefly. Sorry, no, never mind. You're going to double click if you just want to do a quick sort. And then we're going to right click if we want to open up some different options, including a custom sort. That's also where we get to sticks and summarize. All right. So this is just showing a custom sort. Let's go ahead and do some sort of a custom sort. This one is on our road segments data, and that's looking at operational width from smallest to largest, so from narrowest roads to widest roads. We would see them listed that way. And then the next thing they would be sorted on is the number of through lanes from smallest to largest. So you'd start with, if let's say you had several 6-foot wide roads with one lane, and if there were any with 2 lanes, you'd get 6-foot wide roads all listed first by 1 lane first, and then 2 lanes, if that makes sense. But let's take a look at a custom sort here. Let's try one. Custom sort. We can do it based on culvert size. From smallest to largest, and then culvert size, and then maybe culvert length. I think we had a length option in here. Let's see if I can find it. Length. Okay. And we'll also do that one, descending smallest to largest. Hit OK. And, descending. That's largest to smallest. I was like, why is that so big? So our culvert size, first from largest to smallest, we've got 180. That's big because 72 is 6 feet. So that's a huge culvert on 40th Avenue. All right, that must be, yeah, that's big. And then, so we go from largest to smallest here. And then if we look at culvert length, it will follow where the longest ones, the longest 72-inch culverts will be at the top and then following from there. All right, so that was our custom sort example. What do I want to show you guys next? Let's take a look at summarize. So we're gonna, we can open the summary statistics pane by right-clicking on the heading, and we choose summarize, yes. And then we're going to choose the parameters for each of the fields that we want to summarize. And this is actually going to create an independent table, and which will be stored in our default geodatabase. So let's go ahead and do this. Let's do a simple summarize first. And let's see here. So how about we do summarize on, well, let's just go ahead and summarize on culvert size. So we're going to right click, hit summarize. It's going to create a new table. We are not going to use a case field to start. I want to show you what this looks like without a case field. The real power in summarize comes when we use a case field, but we're not going to do that to start with. So our field is going to be culvert size. Culvert size, where do we go? Shape. Eyeballs aren't following today. Oh, there it is. Okay, culvert size. And so if we used sum, it would add up all of the culvert diameters for the entire county. That's meaningless. What does that do for us? Nothing. So I'm not going to use sum. First, that would give us our first culvert size in the list. That doesn't do anything for us. If we were interested in the minimum culvert size and we didn't want to just sort, we could get that. Or if we wanted the range of culvert sizes and we didn't want to scroll through our table, we could get that. I think it's probably more interesting if I want the count, I can just look at the number of records in my, in my attribute table. So the mean culvert size, I think, is a nice one. And then we'll just hit, and it's going to, the output is going to be called, whoops, I scrolled through that, it's mean. The output is going to be called culvert statistics, and the table will be shown both here in our contents. Okay, that's fine. We had some null values in here. That's all right. They were skipped, so we just get the mean of the sizes we actually know. We like our warning boxes sometimes. And then if I look over here in the catalog, and here's my home geodatabase. You can tell it's my home geodatabase because it has a little house on it. And there's my culvert statistics. If I right click on it here, I can open it. And I get the frequency, that's the number of culverts that it calculated this from, and the mean culvert size is 15.7 inches. All right, so a little over a foot. Probably skewed a lot by that big old 180-inch culvert, I'm guessing. But there we go. So that's kind of neat, but honestly, we can do the same thing with running statistics faster. And so where we really get our power is when we use the case field. And so I'm going to kind of show you what that looks like now. So if I was going to do, I can do culvert size again, and I can choose, let's see, summarize. The case field I'm going to use is actually, let's look at like the culvert shape maybe, because there's kind of some different shapes, and I want to see, hey, what's the size for most of the. So I'm going to look at the mean size for each culvert shape, and it'll automatically default to the same name every time. So you want to change something here so you know what, so you don't overwrite your original table, and so you can see what it looks like. So I'm going to be looking at like culvert shape. Okay, and run that one. also added to my catalog. It did have no values, we know that, but if we right click and we open this table now I see, okay, so a lot of the culverts don't have any shape given. In fact, it's like 12,000 of them have no shape given. But if they have no shape given, their mean size is 15 inches. We have 2 empty culvert shaped fields, and those both had a size of 30. Another empty field, which must have had a space or something in it, so it didn't group with these, or 3 of those, they had a culvert size of 4 inches. That's kind of suspect. This is a great way to like proof your data entry, like because somebody was behind a computer typing this information in, right? Our bottomless arch culverts, there were 9 of those. They averaged about 16 inches. Our closed arch, we have 13 of those. They averaged about 39 inches. Bottomless arch are like oftentimes meant for fish passage because you get like a natural substrate bottom for the stream there. These aren't that big though, but I'm okay with that. Box culverts, 26 of those at 31 inches, so those are bigger as well. Bottomless box culvert, 5 of those at 27 inches. Let's see here. Closed box culvert, 4 of those at 56 inches, that's big. Circular, we've got over 1,000 of those, and circular pipe, 12,000, and we've got the average size there. Elliptical, 14 of those at 9. Then we have our not applicable with a dash, slash, and a. These are both the same. Apparently the culvert shape is, somebody entered it in the field as not applicable. We've got 46 at 14 inches and 1 at 30, so that's the data entry error. So you can kind of see that in the attributes table, and we might want to clean it up. Other, culvert shape other, 3 of those at 10 inches, and then a pipe arch at 1 of those at 48. So I thought maybe that is supposed to be a bottomless arch, but anyway, sometimes people enter something that's non-standard into a data form, and this is how it comes out. But that's what the case field is. It's going to organize information by a category. So if you have some categorical variable, also known as a text variable, categorical or text variable, that would be your case, and then you're going to summarize it based on the statistics of another numeric or quantitative variable. So my categorical variable was culvert shape, categorical or text, and then my numeric or quantitative variable was culvert size. All right. Let's practice one more. I think I'm going to have you run ahead of me, and you'll actually take a screenshot of this for one of the tasks for this segment. Let's see. We are going to create a table using Summarize with the mean width of roads by the different surfaces. So let's go to our road segments, just our full one, not just the ones vulnerable to erosion. Let's open that attribute table. And so what I'd like you to do, see if you can set it up ahead of me, and then I'll walk through it with you. And if you need to, you can just pause the video for a second while you do it. But what you're going to do is you're going to use Summarize. You're going to summarize the mean width of roads by their different surfaces. So if we go over here to surface. There we go. Surface. This is where you're going to start out. Okay. We're going to go to Summarize here. All right. So go ahead and set that up. Pause if you need to. See what it looks like. And then you can follow along with me in a moment. And here I go. So we got to give it a different name here. So road segments, no case statistics. No, I don't want that one. I want road segments. Let's see, it's going to be width by surface. So I don't want the number of through lanes. That was from an old search. I'm going to do the operational width. I'm going to get the mean operational width by surface type here. Okay, so this is going to give me, I'm looking at the attributes for road segments. I'm going to get the mean operational width by the type of surface that the road is prepared in. Bam. All right, let's open that up. Let's see what we have. All right, so you can go ahead and enlarge yours, take a screenshot. So we've got basically 11 different types of road surface. Let me open this up a little bit so we can actually see that full. Okay. I wonder if at some point these are just supposed to be combined together because there's over 3,000 here and just 2 of that one. So like I said, again, it's a great way to kind of quality check your data, especially for these big data sets, right? With thousands and thousands of features. And it looks like our mean width for basically paved roads is, these ones are bigger, but 47 to 36 feet, somewhere in there. Just graded and drained. Those are going to be, you know, pretty primitive roads. We're looking at 12 feet there. There's only 171 of those. Let's see, 51 Portland cement concrete. I know sometimes we do that on high use roads because the cement doesn't deteriorate as quickly as our asphalt. So that's interesting. Maybe some of you will end up working for a municipality and GIS, useful stuff. Okay, so go ahead and take a screenshot of that. I think it's kind of interesting. Hot mix asphalt, Portland cement concrete. We've got 9 segments there. That's our widest. Those are maybe segments of interstate, I'm guessing, because that's really wide. Okay, so we got that. What are we doing next? I think we're going to look at statistics. So let's pop back into our PDF. Let's see. The output table will be added to your contents and stored in your default geodatabase. Yes, it will. So we just used summarize, and we used it also with the case fields. If you want to explore interactions among multiple attributes, use the case field in the summary statistics pane, and figure 72 shows that, looking at the mean number of lanes for different types of roads. So the types of roads are the field there is FFC, DESC, description of FFC. I'm not sure what FFC stands for, but those are kind of the categories of roads. And then this query looked at the count of those, and then the mean number of through lanes for each type of road. Kind of gives you a feeling for what an arterial means to this county, that sort of thing. Fun fact: my brother is an urban planner, and he does GIS stuff too. One of my brothers is an urban planner, and so he geeks out on this sort of thing and planning for different road widths and traffic patterns and development type of things. So, all right. So let's take a look at statistics now. We're going to use statistics to work with attributes that are numeric or quantitative. Okay, they're not going to work for us with fields that are categorical or text. So we'll open the chart properties pane to view some basic statistics by right-clicking on the heading to an attribute in the table and choosing statistics. Statistics. Let's do it. So back here, what do we want some statistics on? Let's take a look at our culverts. So open our attribute table here, and we need to have, like I said before, we need to have a quantitative field or quantitative numeric. So I don't know, one of my favorite ones on this one is the diameter, because we have that for most of our, hopefully I'm not making you sick by panning back and forth here. We have that for most of our culverts here. All right, I just have to find it. Culvert size, there it is. Oh, I do have year, which might be interesting to look at statistics for. Let's look at year instead. So technically, I mean, it can only take a certain number of fields. Oh, well, that's boring. So when we look at something like, we run statistics. Sorry, it's kidding. It must be supper time. The program will pop up a frequency distribution. So this is going to be the number of features. So in this case, it's going to be the number of culverts by each year. It looks like everything was in 2019. Maybe one thing wasn't, but it looks like everything was here in 2019. Although the mean is 1992, but I'm not seeing anything, and maybe that's just because there's 1 or 2 out here. So that's not so fun. If I showed you the median, I can pop that on by clicking that box. And the standard deviation, it shows you how much variance we have in the data. Um, Minimum 0, maximum 2019. Lots of nulls. What's our total count? That doesn't make sense. Maybe it's just the count of the ones that they calculated the mean for, and then everything else is, yeah, because there's 15,000. Only 2,000 have a date on them, and the nulls are that many. Okay, not so fun. All right, so bag that one. Let's look at culvert size instead. It looks like they just don't have dates for a bunch of them, and a lot of them were from 1990 something. Okay. Let's see, where did I go? Culvert size. So now let's get statistics for culvert size. So statistics doesn't create a brand new table, although it will create a frequency chart. So let's take a look first at the frequency chart. These are ugly. I don't recommend using these frequency charts that are automatically generated with statistics for display in your layout. They're not that interesting to people. It's more for you for exploring the data. So I'm going to repeat that again because in years past I've had many students put these frequency charts in their layouts, and this is ugly, okay? And you can agree with me on that. I know you've got eyes too. But then the second piece is that this is more of a way we explore our data. So what we can see here, we've got the distribution of culvert size, and that means we have the number of culverts that take each of these size values. And apparently we've got a few that are this very small sizes, some at the bigger size. Our most frequent culvert is like between whatever this size is, 11.25 to 16.88. So these are kind of bins. So most of our culverts fall between a foot and 16 inches. All right. But then we do have some that are out here all the way out to, was our biggest one. That was I thought we had one in the hundreds something. Well, we have 6 out here. There may be one out here. I think was it at 120? Well, we can look at the range here. So see, here I'm exploring, right? And this is what you can do here. Minimum 0, maximum 180. So we've got something out here at 180. Yeah, just one. That skews the data a little bit, right? But most of our culverts fall within this 11 to 16 inch range. We see the mean. We can turn that on or off. There's the mean, and you can see that the mean is a little bit this way because you've got that big outlier here. The median is going to be more to that side, and then we see our standard deviation. We've got, a decent deviation, and some outliers there. So we get the count. We had 15,000 rows, but only 2,600 had data for them. And I mean, that's the nature, I think, working for the county, trying to update these data sets and complete them. And you get a year or two where you have a big push for data, and then your resources have to go somewhere else. So that doesn't surprise me. And you've got over 12,000, almost 13,000 nulls because they just didn't have time to collect data on all of those besides just the location. And let's see, our minimum size of 0, which that's not much of a culvert if it's 0, but someone probably just entered that. And then maximum of 180, that's probably some culvert. We should go, actually, you could look at the location, you could highlight in your chart, and you could go visit it to see the county's largest culvert. It could be a field trip, right? Especially if you're in water science. You see if you're in water science, see if you can get Aaron or Dave to take you to the county's largest culvert and kind of assess its function for the stream. All right, so you guys can be all geeky and hydrology together. The sum of the width of all the culverts, that's kind of meaningless for this. Skewness and kurtosis are measures of this data's fit with a normal curve, so that if you were going to do some different statistical tools on it, you could see whether those were appropriate for the data. At a class at this level, we don't need to go into those with more than just, hey, that's what they are. Okay, so that's us running statistics. Let's run it again. I don't know that we need to run it again. We could run it on, let's see, we've got our roads vulnerable to erosion. Let's open that attribute table. Statistics here. What would be interesting, we've got our the length of each of our road segments. If I right click on this and run statistics, the fun thing is that, so, I mean, sure, it's fine, the mean length of these little road segments, I think they probably just set them up in sort of semi-meaningful chunks of each road. But the fun thing here is looking at the sum. And it looks like we've got about 741 miles of road in the county, at least that are for county maintenance. That doesn't include all the roads in the city that are under city jurisdiction. We just have different pots of money and personnel that are going to manage those. But the county roads, we got 741 miles of county roads. So you can get what you want from statistics, kind of dig for what you're interested in. Oh, sorry, those are roads vulnerable to erosion. That's even more interesting. Wow. Okay, that's way more interesting. Let's run that again. Just take a look at it again. That this is just our roads that we designated as vulnerable to erosion, that we've got 740 miles of those, 741 miles of those types of roads. That's interesting, where they just kind of have a surface that's not covered with asphalt or concrete. Okay, well, that's our interesting factoid of the day. Next thing we're going to look at, let's see if we need to say anything in our workbook. Statistics there. Mean, median, standard deviation for the attribute, and you can visualize each of these numbers on a frequency. Distribution chart for that attribute. Yep, we already did that. We looked at clicking those arrows on and off. And we could kind of take a look at, yeah, all those. So we talked through that. You're good to go. Next fun part. Let's go ahead and break the video here, and then we'll talk about generating charts next.